Okay, now my next series of notes involve real-life situations. This is where we're going to use the z-score formula, and it does convert data values to z-scores. So everything's the same, except with the normal distribution that's not standard, we're going to have real-life numbers to use. But everything else is done the same way. So the normal standard curve has this mean, and then it actually has an x that represents the data value. So x represents any data value. X is the data value. A real life data value. And what this formula does is it converts the x into z. And so let me show you with an example or two. We're going to convert this x value of 36 to a z value, or z squared, what I call it. So what we're going to do is use the formula z equals x minus the mean divided by the standard deviation. X is 36. The mean is given to be 25, and sigma, or standard deviation, is 4. So 36 minus 25 is 11 over 4. And if you type that in, or if you do it in your head, you get 3.75. Just to show you, I wasn't lying to you. And we do want the decimal value. I always round z-scores to 2 places. I'm missing everything left and right. I knew better. 2.75. Learn from my mistakes. Now, where would this z value be on a standard normal curve? 2.75 would be somewhere way over here. Because z equals 0 is in the middle. If you want to actually look at a normal curve, not standard, the mean would be 36. Not bad. I hit myself. The mean is 25. See that? And then 36 would be somewhere over here to the right. Just like it corresponds over here. It's the same thing. Mean corresponds to z equals 0. Data value corresponds to z. For the next example, I'm just going to do the z-score. It's the same kind of question. X is 21. Mean is 42. And standard deviation is 8. So 21 minus 42 is negative 21 divided by 8. 8/16. Negative 2.58 is 625. So negative 21 divided by 8. Just to show you that I do know how to add and subtract and multiply and divide. That's the only reason why I did that in my head. And so, once again, if I were to draw the picture, negative 2.625, there's z equals 0, negative 0.625. Remember, we're going to round these up to two decimal places. So it'll be negative 2.63. It'll be way over here somewhere. We always do 2 places. Now here's some real life examples. Suppose that the scores on the test are normally distributed with a mean of 75 and a standard deviation of 10. What's the probability that the student scores below 70? So if I use the x notation, it's like that. However, I'm going to convert that to a z. So what I would do then is, and I probably don't, I'm going to do it like this once, and from now on I'm just going to do it to the side. What you do is you use the definition or the conversion factor. X is, by the way, x is 70. Mean is 75. And standard deviation is 10. And so that's going to be a probability that z is less than 70 minus 75 is negative 5 over 10, which is probability that z is less than negative 0.50. I'm going to do this once by hand, and then because once you have, I may do another one by hand. Then once you have that, you're going to find out there's something that's way easier. You already know what those are. We've already been doing them. Let's go ahead and finish this one up with our table. So I'm using the table. This is the table approach. So z less than negative 0.50. So everything is actually the same. It's just that we got to convert the given data value to z squared. So we've already done the z less than negative 0.5. This p is just probability notation. That's all it is. So negative 0.5. Negative 0.50 is 0.3085. 0.3085 is the table value. You need to ask yourself, is that the answer? The answer in the question, and the answer is yes, it is, because less than is the table value, because table values give you the area to the left. So the probability is 0.3085. Same situation, but this time the student scores above. Above means greater than. So here's the way I would approach it if I were doing it by hand. I would write that out so I know what I'm looking at. Write this formula out. 85 is the data value. The mean is going to be 75, standard deviation is 10. It's the same situation. 85 minus 75 is 10 over 10 is 1, better known as 1.00. Now what you want to do is you want to do the table value. Table value of 1.00 is 0.8413. 0.8143. And then since there's a greater than, 1.0 is over here. Greater than to the right. There's no way that's the answer. So we need the area to the left end. So the probability is found by doing 1 minus 0.8413, which is 0.1587. 1 minus 0.8413. 0.1587. So what I'm trying to get you to see is once you do the conversion of how the z-score, it's the same situation. Same formula we just did. That one is 2. And what I'm actually going to do is I'm not going to do them by hand anymore. Let's come back up here. Watch this. And I actually need the mean and standard deviation, everything. Watch this. Second vars 2. We want to do left bound. Abbreviate. Left, right, mean, standard deviation. So if you were to draw the picture using 75, or my bad, well, the mean is 75. Below 70, so 75 is the mean, so that's in the middle. 70 be here, be to the left. So that'll be to the left, a really small number. So I might be tempted to use something else, like maybe negative 10,000, because 70 is bigger than what we've been using, which is bigger than 0. We've been using negative 1,000, so I'm going to use negative 10,000. Negative 1,000 may be fine. I'm just going to use negative 10,000 just to be safe. Comma, the data value. That's the right side, the right bound, upper bound. You can lower, upper, however you want to write it. But then, and I'm going to type in the mean and standard deviation. The mean is 75. Standard deviation is 10. Did you catch that? This time, I'm putting in all the numbers. See the answer? 0.3085. Excuse me. Now greater than 85. What's this? If I hit second enter, it brings it back up what I just typed in. This time, I'm doing above 85. The mean is 75, so 85 would be here. Above is greater than. So So that means is this is going to be 85, comma, this time we use a really big number, so just use 10,000, 100,000, what are we going to use? Do I need to, let's delete that one. The mean and standard deviation are the same. Know what the answer is. Put 1587 just to enter. See the answer. But a better way is, as you can tell, stack crunch. So we're doing below 65 with the mean of, or below 70 with the mean of 75 and standard deviation of 10. Stack crunch. Stack crunch. Watch this. See that mean? The mean is 75. Standard deviation once again, 10. It's a less than what? Less than 70. Let's just highlight all that. And type in a 70. Enter. You see, 0.3085. What do we get? 0.3085. See the picture? See the picture? Greater than 85. Watch this. Keep the mean standard deviation the same. Greater than what? 85. You see the answer? 1586, but the 5 rounds it to 7. 1587. Just telling you, nothing better than stack crunch. Let's do stack crunch here. Probability that between 65 and 85, stack crunch. Go use the in-betweener. Keep the mean standard deviation the same thing. 75 and 10, 65 and 85. 65 and 85. Enter. What is that? 0.6827. Let's check out the graphing calculator. We'll close that out. Remember the mean 75, standard deviation is 10. Second of ours, 3. So we have left bound is 65, right bound is 85, mean is 75, standard deviation is 10. So we get the same answer. Argument, don't like that. I hit the wrong thing. Normal CDF, we're doing probability here. 65, 65, 85, 75, 10. And by the way, if you haven't figured it out, I'm more comfortable doing it by hand. 0.6827, believe that. It is true. That technology is really wonderful when it comes to statistics. And then my last example, backwards. I'm going to do one by hand, and then after that, I'm not going to. Let me see which one I want to do by hand. Maybe I've done both by hand. Okay, this time we want to find the IQ score, which means we want to find the data value, which means we want to find the X. I'm going to do one by hand, because these are not much fun by hand. They require some work. So we're looking for X. That's what the IQ score represents, X. And we're given a mean of 100 and a standard deviation of 15. What I'm actually going to use is, I'm using this formula, the Z-score formula. Now what I have so far, I want to find X. I have the mean, I have the standard deviation. I need the z. So what I'm going to do is I'm going to use this information to find the z, which means I can then find the x. So what I'm told is that this area represents that shaded region. So what I need to do is I need to go to the table, which is I'm looking at 0.5675, and the table value is given. So the z-squared is the z-squared for which the table value is 0.5675, because the table value gives you the area to the left, and this is the area to the left. So this is the area to the left. So 0.5675. 0.5675 is right there. 0.17. 0.17. And that's going to be my z-squared in my formula. So now it involves some algebra. So to solve this, you times both sides by 15. And then you add 100. That's going to just do 15 times 0.17. 225, 255. 2.55 equals x minus 100. Then you add 100. I'm leaving no steps out. When you add that to 100, you get x is equal to 102.55. That's the IQ squared. Let's see if that makes sense. The mean is 100, which is right somewhere in there. So this area, this square right here, is going to be a little bit bigger than 100, and it is. Makes sense. 102.55. Yep. Going to show you with the calculator. This is a backwards question. This is an inverse norm. Second vars 3. So we need the area to the left. It's always the area to the left. Inverse norm is always the area to the left. So that's 0.5675, comma. Let me minimize this just so you can see. See that? Comma, mean, comma, standard deviation. This is area to the left. On the graphing calculator. Place. 0.5675. And then the mean was given to be 100. And standard deviation was given to be 15. 102.55. See that? And then of course you should know by now, I am going to use StatCrunch. Just go back to standard. Let's see what the mean. The mean was 100. And standard deviation was 15. I just want to go up and make sure. Yep. 115. So we're going to change that to 100. Standard deviation to 15. And this is a less than. However, we're looking for the z-score, or the x value, I should say. Get that, x value. We're given the area. Area is the same thing as probability. The reason why I say that, because P represents probability. The probability is 0.5675, which is the answer we would get. 0.5675. That's the answer we would get. Wherever this z-score is, or this is the data value. The reason why I know it's a data value, or x value, because of the mean standard deviation. Once we make it 0 and 1, it's a z. If you leave it with real life numbers, it's an x. 102.55. Got that? Is that not wonderful? This one's a little bit different. If you were to do it by hand, the value, by the way, the formula is actually this, in case you want to know. If you take a z-score formula and rearrange it, it's actually that. But in order to use this, I need to know, if I do it by the table, I need to know what that area is. That area is 1.5675. 1 minus 0.1, which is 0.9 or 0.9000. Then I can look at the table value for 0.900, close as I can get to it, which is what, 1.28? 1.28. So the z would be 1.28, and you would use mean of 100 plus 1.28, which is found from the table, times deviation, which is 15. You would take out your calculator, type in 100 plus 1.28 times 15. So that x value, or IQ score, would be 119.2. Which, since it's way over there, it should be way bigger than 100. But once again, we can use our graphing calculator with its features, the inverse norm. But when you do this one, like I said, the area is always the area to the left. So what you could do is, you could then do all the work for you. So instead of doing the 1 minus 0.1 in your head, just type it in 1 minus 0.1, comma, the mean, which is 100, comma, the standard deviation, which is 15. Enter. There you go. Isn't that wonderful? But there's even something better than that. Stack crunch 115. Get the 115. Remember that last example was a curve to the right. The area to the right is 0.1. So the area to the right, the area is 0.1. And so when I hit compute or enter, this x value right there in that box is the answer. 119.22. There you go. There you go. Same picture we have over here. And that is it. A lot of work. But if you want to use StatCrunch and the graphing calculator, I highly recommend it.